All right, guys, right triangle trig. All right, we're going to talk about our 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. And we're going to solve problems and use those identities and those ratios when we're talking about right triangles. What makes something a right triangle?
It's 90 degrees.
It's got a 90-degree angle. Does everybody see this 90-degree angle right here? It's not always in the bottom right, but it will be noted with that little square in the bottom. The side that is opposite across from the 90-degree angle, it's the longest side. It's called the hypotenuse. Everybody with me on that one? Okay. Then you have 2 legs, the legs of the triangle. You have an adjacent side and you have an opposite side. The way that you tell that is they're going to give you an angle, and it's going to be labeled theta. The side that is across from that theta is your opposite side. It's opposite of theta. And the side that is right next to or touching theta is your adjacent side, which is right here. Does everybody see that? All right. We good? Does anybody remember the theorem that we use when you're trying to find the length of a side of a right triangle? The Pythagorean. We're going to use that in the next couple lessons. But a squared plus b squared equals c squared, where c is your hypotenuse, right? Okay. Everybody with me? We're okay. All right, moving along. So we have our 6 trig functions, right? In section 4.2, we talked about when you have an ordered pair, when you're given an ordered pair, when you're finding an angle on the unit circle, your sine value was y, cosine is x, tangent's y over x, right? Then 1 over y, 1 over x, and then x over y. So today, we're going to be talking about those same trig functions, but instead of that, we're going to be talking about opposite over hypotenuse and adjacent over opposite, that sort of a thing. Same concept, same trig functions, but now we're not using angles that are on the unit circle. You're using the actual triangle themselves. What we need to remember, guys, are the signs of things. Remember, this is my x-axis, this is my y, correct? Anything that is in the first quadrant, what are the signs going to be? Plus, plus, right? This is going to be plus, plus. Second quadrant, x is negative, y is positive. Third quadrant, what do we have? Negative, negative. And in the fourth quadrant, what do we have? Positive, negative, all right? Very important to remember. We're going to have to visualize things. They're going to give you the sign of something in the third quadrant. So you need to know, oh, okay, then this value is going to be negative, this one's positive, and so forth. Here's our 6 trig functions. You guys have seen this before. SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So when we have our reciprocal functions, what do we do with them? We just flip. Everybody with me? You guys okay? All right. Again, the side that's opposite or across from theta is your opposite side. Next to the angle theta is your adjacent, and the hypotenuse is the longest side across from the right angle. So if you have something like this, it says use the triangle in the figure to find the exact values. Exact values. Exact values. No decimals. Very important that you guys understand that. On your test or quiz, when it says exact values, that means I do not want decimals. Does everyone see this triangle that we're talking about? Do you see the theta? Do you see the 2 legs, 3 and 4? How would I find the hypotenuse? The Pythagorean theorem, 3 squared plus 4 squared equals c squared. I don't know what my hypotenuse is. So 9 plus 16 equals c squared. What's 9 and 16? So 25 equals c squared. So take the square root. What does c equal? Why isn't it plus or minus 5? Because it's not an angle. It's a side length, right? Do we ever measure length in negatives? Okay, good. So now, guys, if I'm looking at this, let's talk about the sides of our angles. This is my theta. So what is 4? Is it the opposite side or the adjacent? Opposite. 4 is opposite. And what is 3? Adjacent, okay? And 5 is our hypotenuse, yes? Yes. So when you're finding all of the 6 trig functions, I would do this. What did you guys sum the opposite side was? What number? 4. What was the adjacent side? And what was the hypotenuse? 5. A lot of times, guys, if you just look at the triangle and you don't label, you make silly mistakes. If you write out what the opposite side is, what the adjacent side is, what the hypotenuse is, it's really simple to do these 6 trig functions. Sine. If you need to write out so, ka, toa. Sine is opposite over hypotenuse. What's the opposite side? 4 over 5. If sine is opposite over hypotenuse, then cosecant is hypotenuse over what? Opposite. You just flip it. So instead of 4/5, it's 5 over 4. All right, so cosine. Cosine is adjacent over hypotenuse. Well, what's my adjacent side?
3.
So it's 3 over 5, right? So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. So it's what? 5 over 3. Good. Tangent, opposite over adjacent. What's the opposite side? 4 over the adjacent side is 3. Cotangent is flipped. It's adjacent over opposite. So it's what? 3 over 4. Questions? Anybody have any questions? All right, then you come to an example like this. What do you notice about this triangle that's different from the last one? Okay, the hypotenuse is the square root. Another thing we can notice is we don't have to solve for any of the sides. They gave us all the sides already, right? If you have a square root, guys, what does this say right here? They want what? Exact values. What does that mean? No decimals. Can you, and some of you made this mistake yesterday in your quiz, can you leave a radical in the denominator? No, you have to rationalize. WebAssign, for whatever reason, takes it. Sometimes it doesn't, but you cannot. When you're turning in a test or a quiz or something, you have to rationalize. So the first thing I would do with a situation like this is I would label all of my sides. Here is my theta. I always circle my theta so I know what I'm referencing. So in reference to theta, what is 5? 5 is the opposite side. And what is 2? The adjacent. And I know that square root of 6 is the hypotenuse because it's the longest side across from the right angle. Agreed? Now, you can leave it like that and do your work. I personally like to say, okay, my opposite is 5, my adjacent is 2, and my hypotenuse is the square root of 6. It's just easier for me. So now we're going to go through and we're going to find all 6 trig functions. Remind yourself, sine is opposite over hypotenuse. Well, what's my opposite side? My opposite side is what? 5 over my hypotenuse is what? Square root of 6. Can I leave the square root of 6? No. We need to rationalize. So top and bottom by square root of 6. I get 5 root 6 over 6. Questions? All right. Cosine. Cosine is adjacent over hypotenuse. So it's what? 2 over the square root of 6. Can I leave the square root of 6? So I rationalize, and I get 2 root 6 over 6. Do I leave it like that? Nope. What can I simplify? This becomes 1, and this becomes 3. So I have square root of 6 over 3. You can leave it as 1 square root of 6 if you want to. Okay, remind me again what tangent is? Opposite over adjacent. So my opposite side is 5 over my adjacent side is 2. Do I have to do anything there? No. Okay, just leave it. Sine goes with what? No. Sine goes with what?
Cosecant.
Cosecant. If sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So how do I write that? The square root of 6 over 5. Is it okay to have a square root in your numerator? Yes, so just leave it. Cosine goes with what? Secant. So if cosine is adjacent over hypotenuse, your secant is hypotenuse over adjacent. What's your hypotenuse? The square root of 6 over what? 2. Can I simplify that? No. Why not? If it was 6 over 2, absolutely. But the square root of 6 is an odd decimal number. It's not divisible by 2. So you just leave it just like that. And then I have tangent and cotangent. If tangent is opposite over adjacent, cotangent is adjacent over opposite. Yes? What is your adjacent side? 2 over what's the opposite side? 2 over 5. And I just leave it. And there are your 6 trig functions. How do we feel? All right, let's look at our next triangle. It's drawn a little differently. Theta's in a different spot. But again, highlight your theta so you can see what everything is in relationship to theta. The side across from theta. Actually, we need to change this. What's wrong with this?
It's like one side. The opposite is greater than
the opposite, right. The hypotenuse should be bigger. So let's change this one to 11. And let's change this side to, we'll just say 9. Okay, so now let's talk about it. What is 9? The opposite side. What is the square root of 5? Adjacent is the square root of 5. And what is your hypotenuse? 11. Good. Now you don't have to look at your triangle anymore. You can just look at your words and you don't get yourselves confused at all. Some of you, it might be helpful for you to do the sine and then do what? The cosecant. It might be helpful if you do that. Depending upon how it's written or anything, guys, you don't have to do it in order. Do what works best for you. If sine is opposite over hypotenuse, what is your opposite side? 9 over what? 11. Can you simplify that at all? God bless you. Nope, so just leave it. So if sine is 9 over 11, then you know that your cosecant is going to be what? 11 over 9. If that helps you guys to go with the two reciprocals that go together, that's perfectly fine. Your cosine of theta. Cosine is adjacent over hypotenuse. Well, what's your adjacent side? The square root of 5 over your hypotenuse is 11. Is that okay?
Yes.
Okay. So cosine goes with secant. This would be hypotenuse over adjacent. So it's what? 11 over the square root of 5? Is that okay? What do we need to do? Okay, rationalize. Square root of 5 on the bottom and the top. So it's 11 square root of 5 over 5. Questions? All right, tangent. Tangent's whatever what? Opposite over adjacent. Well, what was our opposite side? 9 over? 9 over the square root of 5. Is that okay?
No.
Rationalize. You have 9 radical 5 over 5. Yes? Okay. So then tangent goes with cotangent. Tangent's opposite over adjacent, so cotangent is going to be adjacent over opposite. Look back up at your little notes here. What is your adjacent side? Square root of 5, and what's the opposite side?
9.
So it's the square root of 5 over 9. Questions? It says, given the following information, find all 6 trig functions. Well, they didn't give me a triangle, did they? No, but they gave me some information. When I look at this, they gave me 2 pieces of information. What is cosine of a triangle? What over what? It's adjacent over hypotenuse, correct?
Yeah.
So I can sketch my own little right triangle. Does it matter where I put my right angle? No. When I draw this triangle, does it matter where I put my theta? No. I can put it at the bottom right or the top. That's fine. What matters is where I put my numbers, correct? In relevance to theta, where is the hypotenuse? The longest side across the right angle, correct? This is my hypotenuse. And according to theta, where is the adjacent side? Where is 5? It's below. It's right here. Does everybody see that? So I'm going to find what? I'm going to find the opposite side. I already know, they told me already that my adjacent side was 5 and that my hypotenuse was 8. Did they tell me your adjacent side is, your hypotenuse is? No, but they told us the cosine. So then we can figure out what, since we know the trig function cosine is adjacent over a hypotenuse, we know those two things. So now we're going to find our opposite side. Am I looking for A and B? A or B, or am I looking for C?
B.
You're looking for A or B, okay? Doesn't matter which you put it for. I'm just going to say A squared plus B squared equals C squared. I know my hypotenuse is 8, so I'm going to say 5 squared plus B squared equals 8 squared. What is 5 squared? 25 plus B squared equals 64. Now what? Subtract 25, good. I get B squared equals, what is 64 minus 25? 39, all right. And now what? Take the square root. So B equals the square root of 39. Can I break down the square root of 39? No. If I could, do I have to? Yes. But I can't break it down, so just leave it. So now I know what my 3 sides of my triangle are. Have I solved to find all 6 trig functions? No. But can we do that now? Yes. I'm going to find the sine of theta. I'm going to find the cosine of theta. I'm going to find the tangent of theta. And then we're going to find cosecant theta, secant theta, and cotangent theta. Remind yourself again. I know you guys know this. Just keep it fresh in your mind. Sine is opposite over hypotenuse. What is my opposite side? The square root of 39 over my hypotenuse is 8. Do I need to do anything to that? No, we're good to go. So cosecant is what over what? Hypotenuse over opposite. Good. It's 8 over the square root of 39. What's the problem? The square root of 39. We have to rationalize. So you have 8 root 39 over 39. Questions? Okay. Good job, guys. Cosine is adjacent over hypotenuse. Well, what's your adjacent side? 5 over your hypotenuse is 8. Do I need to do anything? Nope. My reciprocal of cosine is secant, so it's hypotenuse over adjacent. What's your hypotenuse? 8 over your adjacent side is? Perfect. Good. Tangent is what over what? Opposite over adjacent. My opposite side is the square root of 39, and my adjacent side is 5. Is that okay? Perfect. Good job. So my cotangent is going to be adjacent over opposite. What's the adjacent side? 5 over the square root of 39. What's the problem?
39.
I got to rationalize the square root of 39. And I get 5 root 39 over 39. Always check to see, can you simplify? Is anything going to 39 and 5? Those two whole numbers on the outside. Nope, so you just leave it. Scoot over here. Same exact thing. What did they tell me here? Did they tell me the sides of the triangle are this? No. Did they give me a picture? No. But you can deduce a lot of information just by them telling you that the cotangent of theta is 7. Well, first of all, I know that it's not just plain old 7. It's 7 what? Over what number? 1. Okay? That's a very big thing to understand. Remind yourself, please, what is cotangent? It's what over what? Adjacent over opposite. Agreed? So I'm going to draw a quick little picture just so I can figure out what I have and what I'm looking for. I always draw my picture to look the exact same way. You can do whatever you want. They gave me the adjacent side and they gave me the opposite side. How I drew my triangle, where does the adjacent side? It's under the theta. What number, how long is the adjacent side? 7. And where is the opposite side? Across from theta, and this is 1. So what am I looking for? I'm looking for my hypotenuse. Do I have a formula that can help me find the length of my hypotenuse? The Pythagorean theorem. A squared plus b squared equals c squared. What letter in the Pythagorean theorem am I looking for? C. Does it matter where I put a and b? No. 1 or 7? Okay. So 1 squared plus 7 squared equals c squared. What is 1 squared? 1. Plus, what is 7 squared? 49 equals c squared. What's 49 plus 1? So c squared equals 50. So what is c? Square root of what? Square root of 50. Okay. Can I break that down? What can you break square root of 50 into? 25 and 2, right? So what does this really become? What's the square root of 25? So it's 5 root 2. You have to simplify. You have to break down. If you don't, your answer is not completely correct. So this is my hypotenuse. So now I'm going to go through and I'm going to find all 6 trig functions. But I'm going to say, okay, my opposite side is 1. My adjacent side is 7. And my hypotenuse is 5 square root of 2. Everybody with me? All right, now we go through our same thing that we've done a million times in your lives. Sine of theta. What goes with sine? What's the reciprocal of sine? Cosecant. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. I have my cosine of theta, which is adjacent over hypotenuse. So my secant of theta is going to be hypotenuse over adjacent, correct? You guys with me? Mm-hmm. All right. And then tangent of theta is opposite over adjacent. Cotangent theta is adjacent over opposite. I think this is a really good habit for you guys to get into. Just going through and just every single time you do this, write these functions. Write out opposite over hypotenuse, hypotenuse over opposite, just so it becomes second nature. You don't even have to think about it on the quiz. Because there's a lot of little moving parts that go along with working these problems out. So let's go ahead. Let's simplify. Let's evaluate. What is the opposite over hypotenuse? What am I going to write? 1 over 5 root 2. Now, when you guys rationalize, you do not have to multiply by the 5. If you do, it's fine. You're just going to have to do extra simplifying at the end. But the only thing you have to do is multiply by the root. So I'm going to multiply by the square root of 2 on top and bottom. 1 times the square root of 2 is what? The square root of 2. 5 root 2 times root 2 is what?
5 times 2.
It's 5 times 2. Very good. Because the square root of 2 times the square root of 2 is the square root of, guys, square root of 2 times the square root of 2. Square root of 2 times the square root of 2 equals the square root of 4, correct? What is the square root of 4? It's 2. So you cannot forget, you've got to understand, you've got to remember that square root times the square root, the root goes away. So this becomes the square root of 2 over 10. Can I simplify that? No, because one is underneath a square root and the other one is not. So it's just the square root of 2 over 10. So let's scoot over. Since we found the sine, let's find the cosecant. What is your hypotenuse? 5 square root of 2 over the opposite side, which is 1. What's my answer? 5 square root of 2. Can you leave it 5 square root of 2 over 1? Absolutely. That's fine. Adjacent over hypotenuse. What is the adjacent side? 7 over the hypotenuse, which is? So it's 7 over 5 square root of 2. What do I need to rationalize by? Just the square root of 2. If you guys did 5 root 2, that's fine. You're just going to have some extra multiplying, and you got to simplify at the end. But again, I have 7 times the square root of 2 over 5 root 2 times the square root of 2 is 5 times what? 2. So it's 7 root 2 over what number? 10. If you could simplify, if that was an 8 out in front on top and a 10 on the bottom, you would have to simplify those numbers on the outside. Always check to see if you can simplify. So now I'm going to scoot over here. I just found the cosine. Now I'm going to find the secant. It's hypotenuse over adjacent. Remind yourself, what's the hypotenuse? 5 root 2. The adjacent is 7. So it's 5 square root of 2 over 7. Can I do any simplifying?
No.
So it stays just like that. Last two. Tangent, opposite over adjacent. Opposite is 1, adjacent is 7. So I literally write 1 over 7. Anything else? No. And cotangent is 7. 7 over 1, however you want to write it. But remember, that's what they gave us at the very beginning. How do we feel? This is not horrible. Good, I like it. Tomorrow, we're going to talk about our 30, 60, 90s and our 45, 45, 90s. 1, 1 square root of 2, 1, 2 square root of 3. And we're also going to talk about angles of elevation and depression, and we're going to have some word problems. So that's what we're going to do tomorrow. I want to bring your attention to some stuff on WebAssign. Hang on.